Okay, when it comes to fraction, addition, and subtraction, a lot of times fractions, you'll teach multiplication and division first because it's a little bit more straightforward, okay? Fraction work, thinking about something like 2/3 plus 3/4. Now, some of the rules for fractions are very generalized. So for addition and subtraction, you have to have the common denominator. Why do you need a common denominator? What is a common denominator? Okay. Taking a minute and looking at the bottom numbers. If you remember about fractions, this bottom number tells us more than we think it does. Okay. This tells us how many pieces make a whole, as well as tells us the size of the pieces. Now that second part is key for why we need a common denominator. Do I want to add and subtract things that are different sizes? Apples and oranges, okay? If I'm going to add big things and small things together, can I really say how big any one thing is? No. I want them to be universally sized, okay? And so as such, that's why we need these to be the same. The denominator tells us then that we have the same size pieces, okay? So as we do that, and I do these in a vertical setup because now I can work off to the side and then I'll have a final answer over there. So it's kind of an organizational thing that I have a preference for. So when I'm looking here, how do I get the same size pieces, right? It has to be done by multiplication. So you probably know the process. There's the discussion about you write out all the multiples of 3 and 4, and then you see which one is the same in both of them and which one's the lowest. That's why it's called the least common multiple. Okay? You can actually do it by just multiplying these two together. Okay? In the case of 3 and 4, it comes out to be the lowest one anyway. There are other ones where it doesn't, and you find a common denominator, but it will take a little bit more reducing at the end. Okay? So, finding the common denominator of 12, say what is 4 times something equals 12? Well, what is that something? How am I going to know what it is? 3, right? And I have to do the same on top as I do on bottom. And it's a rule that we say, what does that even mean? Take a close look at 3 over 3. That equals 1. If I'm multiplying and I don't want to change its value, I need to multiply by 1. So 3 times 3 equals 9. So 3/4 and 9/12 are the exact same value, but they're in two different forms. This one is not usable for our problem. This one is, okay? So when I come home after a long, hard day's work, my wife is already looking fantastic and ready to go out for the evening. I'm not there yet. I need to change forms. Do I change who I actually am? No, okay? So I'm not gonna change my identity. I just change how I look. I go and I get showered, clean up myself, so that way when I'm ready to go out, I look up to par with my wife and we're okay to go out now. Okay, I look good enough and we match. That's kind of the thing that needs to be in there. Now that we have common denominators, we have the same size pieces so we can add or subtract them as it works. Okay? So I add these two together and I get 17 over 12. Okay. Now here's the other thing for addition and subtraction of fractions. Okay? Not only do we have to have common denominators, but a lot of times we may get something like this, an improper fraction, or we'll run out of stuff, which I'll get to in a second. Okay? So 17 over 12, this is an improper fraction. The top is bigger than the bottom. We're not okay with that. Okay? Sometimes we leave it that way and say leave answers as an improper fraction. Okay? Other times it says make them into a mixed number. Remember, a mixed number is just a whole number and a fraction part. Here, how do I make this into a mixed number? I subtract 12 from 17, and as many times as I can do that is my whole number amount, okay? So I can do 12 minus 17 one time, and then I'm left with 5 as my remainder when I subtract it. And we're still saying that those pieces are the same size, they're 12th size pieces, okay? So that's an important aspect that plays in here of carrying and borrowing with fractions, okay? So essentially this had more than it's allowed to have, more than 12. So it had to carry over into one whole unit, and I still had 5/12 units, okay? Now we do that same kind of thing carrying with tens, and that one works really nicely in our base 10 system, okay? But what does it look like if I have to borrow, okay? So borrowing with fractions is all about the denominator as well, because we say not only how big each of those pieces are, but how many there are in a whole unit, okay? So if I have 5 and 1/3 minus 2 and 2/3, okay? Common denominator, you could do that kind of stuff in a little bit more complex problem. Let's look at this one. Can I do 1/3 minus 2/3? No, I cannot, okay? So here I have to borrow, crossing out my 5 becomes 4, okay? When I borrowed 1 unit, how many thirds are there, right? Looking at that denominator, how many thirds are in 1 unit? 3 of them. So I borrowed a 1, and that shows up as the 3/3. Okay, so that 1 that got borrowed here is 3/3 over there. So that means 4 and 4/3 is the exact same value as 5 and 1/3. Okay? Catch that? 4 and 4/3 is the same value as 5 and 1/3. But now that's the usable setup. I can do 4/3 minus 2/3, 2/3, and 4 minus 2, 2. Okay? So it works out here. Borrowing is based on our denominator. We have to see how many units there are and what size they are. Okay? So that way, as we borrow, we will get an improper fraction, but when we subtract, it becomes regular again. Okay?